What will you do with your final hours? Yes, your final hours. We'll talk all about your final hours today on the Daily Space Weather, as it is indeed the final hours of winter for the Northern Hemisphere. We don't usually start out zoomed in on sunspots like this, but this series of about 4 sunspot groups in the southeastern limb is sufficient to gain our attention. We've already seen one M-class flare earlier this morning from it. It hasn't changed too much in the past 24 hours, which is the amount of time reflected in our custom HelioViewer movies. Likelihood of large solar flares, nearly 100%. Here are some other wavelengths. Now we've added 171 plus 211 angstroms. And that dark region over on the right, that's a very well-defined and quite large coronal hole of South Pole orientation. Here's 304 plus 193 angstroms. And let's take a moment to view the rest of the solar disk. We don't want to be fixated. We want to view solar activity from a holistic perspective, as our channel is interested in cosmology, hence studying the heliophysics. So here is our northeastern limb, and thanks for leaving a comment. Huge filament up here. And that was named the Gene Simmons filament. If you want to name filaments, join us over on Twitter. Perhaps name this one the Paul Stanley, or, I don't know, Ace Frehley, whatever. There is another large sunspot, at least, up there in the northeast as well. Here's our northwest. There is a huge equatorial filament that is crossing the solar equator there, right on the western limb. You should be able to see that a little bit better on the full disk view. Huge prominence over here. Huge prominence over here behind these giant sunspots as well. Let's take a look at the full disk view yesterday plus today. Oh, also, you should note that there is a huge reorientation of plasma here around this coronal hole. Check it out. You can see some plasma, serious, huge amounts of plasma there moving around, partially closing that coronal hole. You can see it open. You can see it close a little bit. Those are cool spots, at least in those wavelengths, 304 plus 193 angstroms. Those species of helium and iron, they don't want to be around that area for whatever reason. It gives us interesting insight into solar activity, solar behavior, and perhaps heliophysics itself. So here's yesterday plus today, the full disk view. That's SDO intensity gram. And most of the groups on the visible part of the disk have remained stable here, although this one evaporated and then reformed. So that one there, you can see it go away, and then whoops, it came back. Also, there is a little bit of umbral migration happening here. Some of these umbrae moving toward the equator, which should also show up in the colorized magnetogram imagery. Again, huge likelihood of large solar flares in your final hours of winter, and a likely glancing blow coronal mass ejection impact to strike midday tomorrow. Let's take a brief look at planet Earth here. It looks like a volcanic uptick. We've got a huge number of volcanoes on the list. We'll blast through those. Shivaluch producing a 24,000-foot ash plume. That's a major uptick there at Kamchatka. Flight level 240 over Kamchatka from Shivaluch. Sakurajima, flight level 070. Subanosejima, we're not sure the size of the ash cloud from Subanosejima. Please do not pole vault to the caldera. Please do visit our links. Which, by the way, do not pole vault to the caldera is our bestseller. Mount Ibu also exploding, flight level 070. Semaru, flight level 140 as it explodes. Dakono exploding, flight level 070. Samisa-Pochno has had its alert level raised to orange as low-level ash emissions have continued from the north crater of Mount Young over the past 24 hours. Gas and steam emissions also seen at Samisa-Pochnoi. Popocatépetl exploding, flight level 210. Santiaguito, sporadic emissions there. Mild explosive activity from the Guatemalan Santiaguito. Fuego exploding, flight level 160. It's a 16,000-foot plume of volcanic ash from Fuego. Nevado del Ruiz, sporadic emissions. Sangay in Ecuador, effusive explosive eruptions continue there. 20,000-foot ash plume, flight level 200, as its volcanian eruptions are producing ash columns and pyroclastic material. Revenador exploding in Ecuador, flight level 140. Cotopaxi, volcanic ash not observed. Also, Sabancaya unable to detect, and Villarrica showed intense Strombolian activity. No indication of the ash plume size there. Don't fly your John Denver-style ultralight aircraft or hang glider or other glider over that caldera. Next, looking at seismic activity over the past 24 hours, and it's been quite low, although we've got some earthquakes in some odd places. So a really low number of quakes over the past 24 hours, and some quakes in some not-so-common locations. Although this Anchor Point one, the 5.4 near Anchor Point, Alaska, not super common there, but it was at 65.4 kilometers estimated depth there, so I suspect that probably didn't feel like a 5.4 to those in Alaska. And make sure you let us know in the comments if you felt that quake. We'll cite quakes over a 5 magnitude, and there were only 2 in the past 24 hours. Again, a very low number of quakes here. The other one was a 5.0 at Russia. That came in at 23:05 yesterday evening. Since then, nothing over a 5 magnitude has shaken things up. So we're back to space. This is the past 24 hours in ionized helium. There was an M-class flare. Peak flux was around 2 o'clock this morning. Did it produce some Earth-directed coronal mass ejections? We'll get to it. And let's blast through some more. So here is we've added 193 plus 171 angstroms there to show some great depth of the corona. 193 angstroms shows the extended corona. 171 shows the lower corona. The 10.7 centimeter radial flux has come up to 143 solar flux units. And you can expect a massive uptick in this in the coming days. This could get as high as to 170, 180, 190 in the coming days, depending on if more sunspots rise or if those sunspots grow or if more sunspots form. But at the moment, you can expect this to reach at least 170 here, just with what we have in the eastern limb. 143 is the current number for the radial flux. That is a 1-year graph from Solon.info. Here's your space weather enthusiast dashboard, and looks like they are forecasting some geomagnetic unrest tomorrow. So that is a CME impact there. Expecting a glancing blow. We called it only a few hours after it ejected. That's the NOAA forecast for space weather. And let's take a look at some Earth system data. Here's the past 4 hours of Earth magnetic moment from space, our Geospace Magnetosphere movie. Again, it depicts 4 hours of magnetohydrodynamic pressure. The units are nanopascals. And things are pretty calm here, although there is a little bit of an uptick there. We also did see a period of strong negative BZ signal. We'll get to that here in a moment. First, Earth magnetic moment from the ground. We're going to show North America because there was some high likelihood of aurora kicking up here just in the past few hours. I suspect that is subsiding, and we'll tell you why here in a couple of frames. So that's what's going on over North America. Past 4 hours. We'll also show the full globe view. There's the full globe view. So we saw the magnetic field shift into negative territory there for the BZ, the vertical component of the magnetic field, the BZ on the space weather, on the solar wind data. And a negative BZ has a higher tendency to create induced currents. And induced currents create things like the aurora, telluric currents on the planet, pipeline, railway, power line induction, and so on. So we might see a little uptick here in the KP. We might see it come up to 2.5 to 3 here but it's going to subside right away, I suspect. Current conditions are only a KP1, geomagnetic calm conditions. Next, we'll look at the real-time solar wind data itself from Lagrangian point 1. And this right here is what I'm talking about, this little brief period of negative BZ. This red line right here. When you see that shift negative, we see more aurorae, more induced currents in the Earth system. Positive BZ wants to bounce off the system and pound into it. Negative BZ wants to flow material into the system. Anyway, current conditions are, it looks like there was a little CME impact here too. In fact, that negative BZ was associated with a CME impact. See this signal right here, you can see a shift in the magnetic fields, the phi angle, the density, and the velocity there all at once. It looks like a little tiny CME impact there. Current conditions are 473 kilometers per second for the solar wind velocity. Solar wind density here, 9.1 protons per cubic centimeter. I truncated the 8. There are your GOES magnetometers. Those magnetometer readings are from a geosynchronous orbit at about 23,000 miles of altitude. They are near equatorial satellites there. And let's take a look at the heliospheric current sheet, as Earth has recently moved into a South Pole-oriented current sheet. So we saw lots of fireworks the last time we saw a South Pole current sheet. So we're hoping for some excitement once again. South Pole current sheet depicted there in green. South Pole in red, North Pole in green. Let's take a look at the solar line of sight field plot. And you can see that sector boundary crossing there, the sun's B field depicted in blue, moving off toward the west. Which brings us to coronal holes, and we've got a very well-defined and indeed quite large coronal hole here south of the equator. You can see it in that imagery. Let's bring up the latest image. There's the last image for our line-of-sight coronal hole plot, and here's the past 24 hours in SDO 211 angstroms. You can see some evolution of that coronal hole, some shrinkage and some growage. Growage? I'm not sure if that's a word. Anyway, that's the situation. It is a very well-defined coronal hole, and it's just recently left the south solar heliographic pole and moved up to where it is now. So that's a major change in the solar cycle progress. The movement of that coronal hole away from the south heliographic pole is an indication that solar cycle 25 is continuing on here. There is still some North Pole magnetism around the north heliographic pole, as you can see here. So we're still waiting for that to leave. And until then, and until we see some major field changes and higher sunspot numbers and so on, higher radio flux, we aren't anywhere near solar maximum. That brings us to sunspots. And the likelihood of major flares certainly exists in that area. Those sunspots are more than complex enough, magnetically speaking, to produce large flares. Don't be surprised to see additional M or even X-class flares. We'll be keeping you posted. Here's your SDO Continuum 24-hour video. And that brings us to energetic particles and solar flares. So we do see the proton flux here a little bit above baseline, but nothing to cause really any sort of polar radio blackouts, I don't suspect. Let's just take a look here just to see. So the D region here, let's find that. The D region, yes. We don't always bring that up, but I suspect that it's not going to be sufficient to produce any polar radio blackouts. So let's just see what's going on there. Let's see if there are indeed any polar radio blackouts. I don't suspect so. We did have an M-class flare, though. That might show up here. Let's see. I think that will actually show up. That will have caused some equatorial radio brown and blackouts. but the proton flux not causing any likely deabsorption region. That's the ionosphere absorbing as opposed to refracting radio signals. And not happening at the moment as a result of relativistic protons. The X-ray flux here, peak flux was around 2 o'clock this morning. That M-class flare was an M1.28, and that is the largest flare in over a week. There's the 1 week GOES X-ray flux. And here are our 24-hour 131 plus 94 angstroms wavelength video. And that M-class flare was highly unlocalized. Instead of one really bright spot, it's a very large, bright area showed up there. A bit of a long duration M-class flare also. And let's continue on to remind our viewers to help support the channel by picking up merch. If you haven't checked out the merch shop, if you click the link below the video, you'll find a link to the Redbubble shop. The products will be in order of best selling as opposed to in the order of most recently created, which is what we're showing you here. Today's featured product is... What is today's featured product? Today's featured product is Universum Liberate, which means, well, you can look it up yourself, but it is the motto, the moniker, the tagline, whatever you want to call it, to the Galactic Federation Special Forces. If you've been sick of seeing what's going on in your local household, neighborhood, town, county, state, region, country, continent, hemisphere, planet, and solar system, perhaps you should support the Galactic Federation. If you're wondering what the symbolism means, it stands for the Milky Way galaxy. The key represents signal strength, integrity, and security, and the lightning bolt represents instantaneous galactic scale reach. The little bright spot in the upper right represents it's classified. So check it out, this great design here, very, very high resolution design. All of our designs are like 5,000 pixels and so on. The Galactic Federation Special Forces, tell your friends and foes, Universum Liberate, and perhaps they'll think that you're in the Illuminati. And that will be fun, of course, and thanks for leaving a comment, TinMan1057. And we're looking at a star chart. We want to orient our viewers before we show things like filaments and coronal mass ejections. So the sun not too many degrees off the horizon here, not too many degrees off Mercury either, chasing Saturn and the moon there. We've got an extreme crescent moon there. Right now in the southeastern sky over Lehigh Valley, Pennsylvania. If you want to make your own star chart, head to skyandtelescope.org. That's the one we're using here. Next, the solar system forecast. This is where things are now. We'll advance this 1 week, as space weather is a bit complex. Here's where things will be in a week on the 27th. Earth in an extremely lonely portion of the solar system with 0 gas giants. And I'm not sure what happens there, but I've heard people on YouTube saying that it's very dangerous when Earth is around the gas giants, even though it's incredibly far from the gas giants. When Earth is not near any gas giants, does that mean a time of extreme good fortune? Like if it's dangerous to be near the gas giants, isn't it extra safe to be not near the gas giants? Just saying. By the way, planets do not control the sun. Next, looking at some coronagraphs. And, yeah, there's what's going on. Now, keep in mind, folks, let me just clarify that a little bit. All the planets in the sun, they orbit each other's common point of gravity. They're all orbiting a common gravitational point. However, the sun has most of the gravity in the solar system. So that's anyway, you get the idea. And why is it not playing? So here are some coronagraphs. We do have a number of CMEs. Some people may think there are Earth-directed ones here. I would suspect they are not earthly directed. We do have a little bit of problems with some missing data, but I think we've got enough to both induce and deduce whether those CMEs are earthly directed. That was yesterday. Here's today's frames. That's 28 additional frames from today. And I don't suspect those are earthly directed, but let's take a look at Stereo A and Soho Lasco C3. Now, we paused these. Stereo A is paused at just after midnight yesterday. That's 9 o'clock. There's 9 minutes after midnight, and then there's 9 hours of missing data there. But that's not on the Earth side. That is certainly on the way off to the west, and you can see that here on the Soho Lasco C3. And you see this southern CME. That was at about 1500. Also not earthly directed. And besides that, lots of missing data there, but we don't see any significant, I don't think any of those are earthly directed. If they are quite diffuse. Here are some 24-hour videos. Again, you'll see some missing data here, so what's happening is Soho Lasco C2, the red portion, has more data than the C3, so there's a little bit of a time-lapse-like effect happening there. We also included 193 angstroms for the SDO portion of it because we want to be able to see any large plasma tufts. At the moment, things are fairly constrained here, so there's the full zoom. So a minor CME impact expected tomorrow, major flaring likely at any moment, basically. And massive sunspot group in the southeast, containing possibly the largest single umbra of solar cycle 25. I don't measure them or do anything like that, but there's a lot of estimation that goes on, and that is quite a large sunspot. If you want to name filaments after living people, make sure you do it on Twitter. You can't do it in the YouTube comments. I'm thinking about naming this one Paul Stanley, but I'm largely leaving it up to our viewers. So also this huge prominence over here could get a name. That's the ground-based Hydrogen Alpha Solar Observatory. They're part of the National Solar Observatory in El Teide, Spain. We're almost to bonus features. First, a quick reminder, make sure you join us on Twitter. If you haven't, you'll miss stuff because there's exclusive content over there on Twitter. You can also find a link to the free mushroom gummies giveaway. If you haven't tried the Hemp Lucid mushroom gummies, check those out. This is the link. This is where the link will send you if you click the link, which is pinned to our Twitter profile for your convenience. So here's the past 24 hours and 193 angstroms. And that coronal hole there looking like it's not really wanting to migrate very much farther north. Another indication that we've got a long way to go to get to solar maximum of solar cycle 25. As this magnetism will end up all the way up here by the next solar minimum. So that's the past 24 hours. Here's the past 2.5 hours. The great wide field of view from the GOES 16 SUVI. I think this one might be appropriate to name the Bernie Sanders filament because it's prominent and it's setting. Yeah, prominent and setting. All right, so here come bonus features. Satellite charging hazards are currently non-existent. If you want to follow them yourself, head to the satellite's community dashboard. At the moment, no charging hazards of the surface or internal charging variety. GOES electron flux pictured here for the past 3 days as measured by the GOES 16 and GOES 18 from their geosynchronous near equatorial orbits. They're using radiography, and they measure the electron flux at the F layer of the ionosphere. And here's a little uptick in the electron flux, which I think I forecasted yesterday. See yesterday's video to verify whether or not I was correct with the forecast. I think I was doggone close. There's the 1-year graph to put it in context. You can view that if you like at solon.info. And here is the F-layer. We'll show the vibrational frequency of the bridge between Earth and space. The F-layer of the ionosphere is located at about 300 kilometers of altitude. And here's the vibrational frequency of the F-layer. So certainly a lot of high-frequency anomalies happening here. So now keep in mind we are approaching, literally the equinox happens today. So the time of the equinox is the most geomagnetically active time of the year. It has to do with the angle of attack of the incoming solar wind. Here's your anomalygram, by the way. That's anomaly in megahertz from a 30-day median. You'll see a lot of blue here. As I was saying, the Russell-McLaren effect, it has a tendency to accelerate high-energy electrons in the outer Van Allen belt, and that's sort of one of the many things that occurs there as that puffs up. And the Russell-McLaren effect, if you've never heard of it, that's what is the cause of the higher levels of geomagnetic activity around the equinoxes. It's basically just because the planet's magnetic field is roughly perpendicular to the incoming solar protons, and that creates the highest amount of braking when those protons reach Earth's magnetic moment. Anyway, here is the latest image. We'll let that play through one more time here. Again, lots of anomalies here, both of the low and high frequency variety. There's 1145 universal time ionogram and 1145 universal time anomalygram. We'll also show the total electron content. That'll show you the most likely places for GPS errors. We're going to show the world view as well as the North American and US view. So there's our total electron content. It's still quite organized here. Electrons mostly where you'd expect them to be. That's about 12,500 miles of electron content. Here is the North American 10-day anomalygram. That's anomaly from the 10-day median. Some significant electron anomalies happening there over places like Mexico and the Eastern Pacific. And here's just the U.S. by itself, the lower 48. That's your total electron contents. And we'll close out the space weather video as we do with the latest magnetogram and intensitygram. And yowzers, that is some major umbral area right there. If you were wishing for a grand solar minimum, please turn off the video now and unsubscribe from the channel, because this is not a grand solar minimum. And if you put all your eggs in one basket, you might as well sell some, because they cost like $10 a dozen. So very magnetically complex area there. One thing that's interesting is that this group right here, it looks like it's all North Pole umbre there. So now that may be considered part of this group, but that looks like at least 3 sunspot groups to me. Let us know in the comments what you think. If you've got some other ideas, it could even be considered 4 suns. I would actually consider this 4. I would consider this 1, 2, 3, 4 sunspots. But anyway, doesn't really matter. It's all fairly arbitrary. What really matters is the big picture. And there we've got a great view of some groups there. Interesting over here, this one has only South Pole umbre, it looks like. Hang on a minute, let's zoom back out. Oh, I stand corrected. Yeah, so there's a North Pole umbre, and then there's 2 trailing South Pole umbre there. So that's a beta gamma class sunspot, maybe even beta gamma delta class. certainly beta gamma class. And over there, that's a big sunspot. And it looks like there's another one. Yeah, another one just rose or formed right there. So that'll be another named sunspot group today. Probably. It might not get named until tomorrow. Anyway, there's the full disk rockback. And it's time to move into bonus features. Before we do that, today we'll have a bonus feature. It'll be our YouTube exclusive live stream. So we'll be streaming exclusively to YouTube today for the equinox. We'll start around 5 p.m. Eastern time. So make sure you join us for that. We'll be talking about whatever you like. Not just things like space weather, perhaps news and politics. Who knows? Maybe just random entertainment, shooting the you-know-what, or maybe even stuff like recipes, or what about fitness advice from an actual athlete? What will you do with your final hours? Your final hours of winter. Or, shout out to our viewers from below the equator, south of the equator. What will you do with your final hours of summer? Hopefully you'll spend them with us as we do a rare YouTube live stream. If you want to support the channel, visit our links. You can find them on the homepage, the official homepage of the Smash News Network, Least Busted Name in News, and welcome to the Neo-Renaissance. Yeah, we're writing a paper explaining the solar sunspot cycles. It's pretty serious. So help us out by visiting our links, becoming a member of the Smash team, getting involved in other ways. Thanks to everybody who has. You can find the link to the Hemp Lucid shop right there on the homepage or below this video in the description. If you're viewing on BitChute, make sure you view the videos on YouTube. You're missing about 90% of the content. Although we do still have the links in the description. So visit our links, help us out that way, as we're paid just this side of nothing to put out the content. And if you want to support the channel on a monthly basis, similar to Patreon, consider becoming a member of the Smash Team. Smashomash.com/Smash Team, launched back in October of 2021. We have a gold, we have a silver, we have a bronze, and we have a gold annual paid-up subscription level. We've already explained the likely mechanism underlying the solar sunspot cycles to our gold members. So also, if you want to, at smashomash.com email address. That's another feature of a gold Smash Team membership. And let's move to meteorology. So what we're looking at here is the Gulf Stream. Why? Because I want to forecast a year without a summer for Europe. Yeah, look, folks. Oh, my God. Oh, noes. It's a year without a summer coming. Just kidding, folks. Pardon my sarcasm. The Gulf Stream is still making it up to Ireland and Iceland, as you can see. What you're looking at here is currents. So the movement there, that's ocean currents, like the Gulf Stream. And you've got sea surface temperature, which is the coloring portion. So you can see that warm water there, making it up to Iceland and Ireland, as you would expect. If somebody was forecasting a year without a summer for Europe, you can cancel that forecast. Now, we do see some cold water coming down here, but it's not melt time yet, so it should be an interesting summer, an interesting spring melt season, especially since we've had a 7th consecutive winter of record snowfall for the Northern Hemisphere. So that's always interesting, and it seems to be a data point that certain people don't want to talk about. Now, I talk about all data points because I'm interested in the truth, not advancing my own theories, because I'm only interested in advancing any theories that are correct. Anyway, that's sea surface temperature and ocean currents. There's the Pacific. There is the Indian Ocean. What about the Atlantic? The Southern Ocean, we've got that covered. Just saw a story this morning on record low sea ice around Antarctica. The article on SciTech Daily did not reference the amount of ice sheet, snow and ice. There's the Arctic Ocean, and let's switch to our regularly scheduled surface wind and jet stream coverage. So here are the wind patterns around the planet. There are the surface winds of the eastern world. There are the jet streams of the eastern world. There are the jet streams of the west, otherwise known as the Americas. And here are the surface winds. Surface winds of the central world depicted here. And there are the jet streams of the Middle East, Africa, and Europe. Now, today we're showing the visible satellite. We usually show the 3.9 nanometer radiation satellite to show clouds and fog over the Americas. This time we're using the visible because it's late enough in the day, and we also want to show the fact that that shadow is almost perfectly vertical. It'll be perfectly vertical at 5:24 and 20 seconds Eastern Daylight Time. That's 5:24 p.m. today on March 20th, because that is what the equinox is. That is when Earth's axis is perpendicular to the sun's equator, that is. And also, the equinox is when Earth's equator crosses the solar equator That's what an equinox is. Anyway, here's our weather.gov map, and we've got huge hard freeze warnings for the southeastern U.S. Some cold temperature anomalies coming. We've scrolled down to show you the key. If your location is lit, click your location on the map at weather.gov, and we've got lots of snow warnings there. Some winter weather warnings happening. First, we'll do a temperature anomaly forecast. There's your GFS 72-hour temperature anomaly forecast in degrees Celsius. We've got some warm weather coming back to the mid-Atlantic states. We're excited about that. Kick off spring the right way with warmer weather. Next, GFS 72-hour pressure and precipitation forecast as California continues to get pummeled with shocking amounts of precipitation. We've also got the 72-hour GFS total accumulated snow depth change in inches. And once again, portions of California there forecasted to receive over 3 additional feet of snow. So that's an interesting way to kick off spring. And also check it out, all the hot water coming out of, all the hot air coming out of Colorado isn't putting people in hot water at all. It's making people extremely rich. The purveyors of hot air and utter nonsense from Colorado, their hot air is not going to prevent additional snowfall there, at least for the western part of the state. Let's take a look at the difference between the Euro and the GFS model. So there's new snow for the next 3 days on the Euro model. And there is the GFS model. Again, that's new snow from windy.com. They got a great mobile app. Check that out if you've never seen the windy.com app. You can download it for free for your, quote, smart, and quote, device. So there's the GFS model for new snow for the next 3 days, and there is the Euro model. Fairly well aligned there for most areas. And here's our lightning mapper. We like to see where the strong storms were, and at the moment, for the past about 10 hours, it's been pretty calm here around North America and Central America. Here's our real-time lightning map, and do we have some terrestrial strikes? Nope. That real-time lightning map is from lightningmaps.org, powered by blitzertung.org. And let us know in the comments if you, like I, believe that German is the best language to yell at somebody like a psycho. I think it's the best language to yell like a maniac. Ich möchte ein Bleistiftspitze. That means I would like a pencil sharpener. All right, so here's our U.S. Doppler radar map. We'll focus on the lower 48 to close this thing out. Our video got cut off yesterday because the browser crashed. I think we had 92 tabs open. Here is clouds and fog, 3.9 nanometer infrared radiation. And there is your water vapor map. And that is where we'll close things out after our recap. Once again, showing the U.S. Doppler radar. Clouds and fog, despite half of the country still being in darkness. And there's water vapor. Hopefully you're not in darkness. Hopefully we've been illuminating regarding things like space and Earth weather. Hopefully you understand things like atmospheric physics and forecast your own weather when you need to. Impress your friends and foes by forecasting the weather. We'll help you do it. Anyway, thanks for tuning into the Smash News Network, least busted name in news. Congratulations on realizing the channel exists. Frankly, we're surprised. We'll see you soon. In the meantime, I'll have been your host, Dan, a.k.a. Smash-O-Mash. And don't forget to visit the links over here and here and here.